Hello geometry students, this is Mr. Fugay, and our video here today is going to talk about transversal angle pairs, specifically drawings with multiple lines and intersections. So make sure that prior to watching this that you have already either in class or through my video taken a look here at part 1, which introduces a lot of important vocabulary and in addition given you an opportunity to reflect on using those in simpler diagrams involving one transversal and two lines. We are going to level it up in this video and talk about some more complex diagrams like the one you see here on the screen. So we're just going to go through some examples, and just to note some of our vocabulary terms just as a recap from the first lesson. All of these terms that I am boxing in purple, these are special names of angle pairs that occur at two intersections. And then from a couple lessons ago, we still have vertical angles and linear pairs. These occur at one intersection. So that's going to be an important distinction for us to think about as we talk about this lesson. So let's go ahead and let's start with a few. So I'm going to go over 3 of these in particular. So we're going to do the first one, the second one, and then I'm going to do this one, I believe. Okay? Then we'll have an opportunity for you to pause the video and try the other 4 problems that are on here. So let's talk about angle 1 and angle 11 first. So when we take a look at this, what we have to recognize is that every angle pair relationship, when they are at different intersections, involves one connector line, better known as our transversal, and then 2 other lines that form both of those angles. So in the case of angles 1 and 11, which are highlighted here in red, we can see that our transversal, as I will highlight in yellow, that connects them together is going to be line L. So line L is what connects these 2 angles together. Now, furthermore, what we want to gather from this is that the other lines that make angle 1 and 11 would be lines M, as denoted there in green, and line P. So lines M and P create that relationship. Now, when we now finally have taken the opportunity to reflect on what connects them and then what the other 2 lines are, this will make finding our relationship a little bit easier. Because here's the thing. We can basically ignore that angle K even exists at this point, and we really need to isolate our attention on all the stuff that I've colored in. In fact, I'm going to move it over to the side here, away from all the noise of our problem, and just look at it like this. Because when you look at the diagram here, what I can see is that these 2 angles, that would be 1 and 11, are both located on different sides of my transversal. That's the yellow line. And they are also both located exterior to my green lines, the non-transversals. So they are on different sides, which would be alternate. They are both exterior. This would make this relationship alternate exterior angles. Now, I want to bring this all back to the diagram and just quickly reflect on the idea of this complexity as we go through these problems. Because initially, before I went and colored this all in, I bet you some of you saw 11 and thought, well, 11 must be interior because it's inside here. And the fact of the matter is, if we were looking at relationships between this intersection and that intersection, well, yeah, you're probably right. 11 is interior to that. But that's not the specific relationship we're looking at. So when we have complex diagrams, what we need to do is isolate the important information. Every one of these relationships we're going to walk through, when they're at different intersections, has a transversal that connects them, and then 2 additional lines that make those angles. As we move on to the next one, you will see this changes completely when we now talk about angles 16 and 6. Because now when we look at these 2 angles, we have to first identify once again what our transversal is. And the connector line is this time going to be line M. That's my transversal. My other 2 lines that make up 16 will be line L, denoted in green here, and line K, also denoted in green. So L and K are going to be my lines. Just like last time, if we can't see it from this diagram, let me highlight all the information that I've just colored in here, and let's move it off to the side, away from the complexity of the diagram, and really just isolate what we're seeing here. What I am seeing are 2 angles who are located on the same side of my transversal, And on top of that, they are located in between, in the middle of these two lines, which would make them interior angles. So it looks to me that these would be considered same side interior angles. Okay, let's look at one more, and then I'm going to give you an opportunity to pause this to try some of these on your own. So the last one I'm going to do is skip down and talk about angles 9 and 7. And the reason I wanted to highlight this example is to just remind you that when angles, as 9 and 7 are, a pair of angles, are located at the same intersection, we already have some words reserved for that we've talked about in previous lesson. Vertical angles, linear pairs. Now in this situation, it's not a transversal. So there is actually no transversal because there is no line that connects those intersections together because it's only one intersection. That's why there's no transversal. There are still two lines that make up this relationship. This would be lines, I believe it's K. Sorry, it's on my screen there. Yep, K and P. So K and P are still going to be my two lines. So all of these angle pairs are always made up of two lines. Once again, this one might be a little bit easier to see, but if I move it away from all the noise, we can see that these are non-adjacent angles formed by the same two lines. So by definition, these would be considered vertical angles. All right, now it's your turn. I would like you to take a moment to pause this video and see if you can try the remaining 4 examples. Go ahead and pause now. All right, I will assume you have now paused and you have tried these out. So we're going to go through these. I'm going to move through these quick. Remember, you can always pause and rewind as we need to. So 7 and 14, let's highlight those first so they're in front of me. So here's 7, here's 14. The transversal that connects them is going to be line P. Okay, that's line P. And then the lines that make up 14 and 7 will be lines L and line K. So line L, line K. And once again, if we want to try to isolate this information, move it off to the side, we will see this is the one that most students forget about because they are located on the same side of the transversal. But notice that this one is in between the lines. There's my lines. So this one's in between. And then this one is actually exterior. It's outside of the line. So this is going to be none of those other special names. This is actually going to be a corresponding angle. Corresponding, remember by definition, are two angles that are located in the same position. These are located in the upper left corner, right? Upper left corner of the intersection. Both to the left of the line, both above the transversal. So make sure you pay special attention to corresponding angles. All right, moving on to 10 and 6. So 10 and 6 are going to be located right here and right here. Our transversal is K in this case. I'll highlight that once again in yellow. And then our lines are going to be M and P. So M and P. Once again, what you want to do in time is not be able to look at this in the diagram without having to do this little trick like I'm doing. But when I move it off to the side now, we can see that they are on different sides of the transversal, and they are both located between the lines. So that would make these alternate interior angles. All right, 2 more to go. 12 and 11. So 12 and 11 are actually occurring at the same intersection. So much like the example we did when we walked through 9 and 7, there will be no transversal here. They are made up of 2 lines still. That would be lines L and P. And funny enough, L and P spell the word linear pair. That was no coincidence, of course. That was just that was a coincidence, I meant. 12 and 11 are adjacent to each other, and their non-common sides form this nice straight line that makes them, by definition, a linear pair. And for our final practice here, we're going to look at 12 and 15. So 12 and 15 are located right there. Our transversal in this case is line L. So we'll go ahead and draw that yellow line again for that. My other lines, my non-transversals, are M and P, which I'll highlight there in green. So M and P. Now, if you already can see what this is, that's great. But if you need to do what I'm showing you here is to move this off to the side, look at it in an isolated environment, we can see that these are both located in the bottom left quadrant of these intersections. They are in the same relative position with each other, which makes this last example, once again, corresponding angles. So, as I recall, and I will say one last time, make sure for these complex diagrams that you are isolating the important information, identifying the transversal, which is what connects the intersections together, identifying the other two lines that make both of those angles, and then only focusing on those three lines, no matter how complex the drawing gets. I will show you kind of the extreme example as we wrap up. If you look at practice A, at the very end of practice A, there is a wild diagram. As you can see, I've called it challenge at the top, because this is about as hard as these diagrams get. But what I want to remind you is that if we were trying to talk about angles 1 and 11, and you were like, I have no idea how to figure this out, identify your transversal, identify your lines, just like I've done here. And then if it helps, redraw it. If you're on paper, you can just redraw it on the side, or on OneNote like I'm doing, you can use the lasso tool and move it to the side. And now I see this a little bit easier. Both of these angles are located above their lines, and they are located to the left of the transversal. So 1 and 11 would be an example of corresponding angles. No matter how complex this gets, always remember, every one of these angle pair relationships are just simply made up of 3 different lines. So that will conclude this video, conclude this lesson. Be sure to go back and listen to any other parts that I've described here, or go back to the first video for the core definitions of these terms. I hope you all have a great rest of your day, and good luck with your work in geometry.